Hello guys, we're here at NC State campus in the wilderness looking for a wild creature, natural rubber.
Alright, so let's get to know what we're tracking here through some rapid fire facts. Isoprene has a molecular formula of C5H8. It has a density of 5.7 pounds per gallon. It has a boiling point of 34 degrees Celsius and a melting point of 30 degrees Celsius. It has a heat of fusion of 4.88 kilograms per mole and a heat of vaporization of 25.87 kilograms per mole. Its first ionization energy is 15,928.5 kilograms per mole, and it is not soluble in rubber. Back to you, Angelica.
All right, we've got the rubber, you guys. Okay, rubber in its liquid form can be a bit dangerous. It's really harmful if inhaled. It's damaging to the respiratory tract, and if you absorb it through your skin. And of course, it can cause eye irritation. But rubber in its solid form is quite safe. You may be wondering why we've been trying to catch this bloody rubber, but it's because it's a highly coveted product in most sects of the workforce. I have Sonia over there ready to give you more information about that.
Guys, we're here outside Man Hall, which houses the Department for Civil, Construction, and Environmental Engineering. Rubber is a very important component used by these engineers. It's used mainly in hoses, matting, flooring, and as a thermal insulation for many houses. It also serves as an adhesive for several different engineering processes and products. It's also very prominent in the health industry, and it's used as surgical tubing and also as surgical tools. It's also extremely important for occupational therapists who often use rubber in machinery that helps to rehabilitate patients with mobility issues. As you can see, rubber is also all around us. It's used in tires, latex gloves, hair ties, rubber bands of course, and also in erasers. Rubber is very plentiful around us in this world, and almost 23 million tons of rubber are processed and produced every single year. And how does it do all these fantastic things? We're going to have our rubber expert, Kayla, describe all the processes.
Isoprene is the molecule of natural rubber. This is the Lewis dot. It consists of 5 carbon atoms and 8 hydrogen atoms. And then we have 2 double bonds, and the 2 double bonds are the strongest bonds. And then we have also a single bond between carbon and carbon and a single bond between the carbon and hydrogens. So the bond lengths are written up here. The bond length of the carbon to hydrogen is the shortest, that's 1.1 angstroms, where the double bond between carbon and carbon is 1.3 angstroms, and the single bond between the 2 carbons is going to be the longest, and that's 1.5 angstroms. This is a nonpolar covalent molecule, and it has a bond order of 7,6, which is a simplified fraction of 14/12, because there are 14 bonds altogether, including double bonds, and there are 12 bonding regions. Now, the hybridization of each of the carbons is going to be different. So for this carbon up here, it has 4 bonding regions, so the hybridization is sp3. And this is also a tetrahedral, where the rest of these carbons have only 3 bonding regions around them, so that is sp2. And these are going to be 20 degrees between each of these, 20 degrees, where this is going to be about 109.5 degrees in each of these. And this is the overall molecule, and these are all trigonal planars, where this is the tetrahedral. This is the structure of the molecule isoprene.
As you can see, it's all around us. Rubber's pretty fantastic.
Don't you just love rubber?